Types of fluid flow. There are various types of fluid flow: laminar flow, turbulent flow, steady flow, unsteady flow, uniform flow, non-uniform flow, viscous flow, non-viscous flow, incompressible, uncompressible flows. Introduction to fluid flow types. The fluid flow is the movement of liquid or gases, and we can classify into different various categories. So this type of fluid flows plays an important role in engineering as well as in metallurgy and medicine field. Laminar flow. So the laminar flow is in smooth flow. So the flow of a laminar we can determine by using a Reynolds number. So if the Reynolds number value is less than 2000, then the flow is said to be laminar. So this type of flow is characterized by very smooth and orderly motions, and often we can see this often low velocity conditions. So this laminar flow is essential in application such as blood flow in small vessels, oil transports in pipelines. Turbulent flow. So the turbulent flow is an irregular and a chaotic flow. So it is like an which results in mixing and eddies within the fluid. So when the Reynolds number value is less than greater than 2000, the flow is said to be a turbulent flow. So it generally occurs at high velocities when the pipe is of a large diameters. So when the pipe is of a large diameters, it significantly affect the drag and its resistance. So this kind of turbulent flow we can commonly see in rivers, atmospheric winds, which impact the weathering patterns and aquatic ecosystems. Transitional flows. So the transitional flows is an intermediate state between a laminar and the turbulent flow. So this type of flow can exhibit characteristics of both the laminar and turbulent flows, which leads to unpredictability. So understanding this turbulent flow is very important for predicting the flow behavior. So all these types of flows is very important to understand the flow behavior and its characteristics. Compressible flow. So the compressible flow is a flow where the density changes significantly in response to the pressure variations. So we can take an examples gases. So this type of flow is commonly associated with gases. So especially at a high speed near or above the speed of the sound. Incompressible flows. So incompressible flows assumes that the fluid density which remains constant, simplifying the analysis and the calculations. So example is water. So we can't compress the water, so water is an incompressible flow. So this type of flow is typical for liquids and low speed gas flows where the density changes are negligible. Steady flow. So the steady flow is an type of flow at any given point which does not changes over the time. So the fluid properties which does not changes over the time, like the velocity, pressures don't change over the time. So this type of flow is called as a steady flow. So the unsteady flows which shows the variations in velocity and the pressure with respect to the time. So it's very important to analyze the steady and unsteady flows for predicting the flow behavior. Viscous flows. So the viscous flows considers the effect of fluid viscosity leading to the shear stress and energy losses. So the inviscous flows assumes a which is of no viscosities, so allowing for simplified calculations in certain scenarios. So it's the understanding the difference between viscous and inviscous flows is very important in fluid mechanics as well as in the fields of aerodynamics. Rotational flows. So the rotational flows is an type of flows which rotates about the center of mass, which results in vorticity. So when we take some vorticity, we can take it off in two types: free vortex flow and forced vortex flow. So the free vortex flow is, by the name itself we can understand, by not giving any external torque. So that is a free vortex flow. And forced vortex flow is when we apply an external torque. That is an example for forced vortex flow. Irrotational flows, that there is a no rotations in fluid elements, simplifying the potential flow analysis. So both the concepts are very important in understanding the phenomena such as lift generations on an aircraft wings and flow around the objects. So it's very important to understand the types of fluid, because which helps us to know about the flow behavior and its characteristics. So which also aids in designing the efficient systems and predicting the flow behavior in real world scenarios.